oversampling. Jiakim, are you ready? Can you share your screen?
Yes.
Okay.
You can see?
Yes.
Okay.
But I think you need to loud more your voice.
Okay. Here.
Yes.
Okay.
Go ahead.
Let's start. Hello, thank you for being here. This is Joachim, and I am in the Master and PhD combined course of Myungji University Department of Information and Communication Engineering. The topic of my presentation today is lucid CNN model for face image detection with GAN oversampling. I
Go ahead. No problem.
I'll divide my presentation into 5 parts. First, I will discuss introduction. Next, I will talk about related work, and proposed lucid model, and performance evaluation. Finally, conclusion we are going to look at. Let's start with introduction. I'll be talking to you about embedded system. Nowadays, as hardware performance improves, we can use more powerful embedded systems in multiple situations, like on smartphone, camera, in industry, broadcasting, medical, and vehicle. The figure one is one of them embedded systems. Compared to PCs, embedded systems have the following advantage and disadvantages. PCs are highly general and do not need to consider power. On the other hand, embedded systems require consideration of power or batteries and significantly limit hardware performance. But it has the advantage of being more portable than PCs. I have looked at embedded systems before we get to the point we set up a low storage and low computation environments for setting embedded systems. To solve those hardware disadvantages, embedded systems are equipped with special cores for deep learning. These help to handle matrix operation and vectors for effectively. MPU is a neural processing unit that can be customized according to the specific purpose of each manufacturer. TPU is a type of MPU called tensor processing unit. It's made by Google, and we don't need to customize it, the TensorFlow operation. In this paper, we develop a deep learning model that can predict age and gender through facial images. In particular, we propose a fine-tuning model that the deep learning model can operate in a small embedded environment. Let's relate work. In this paper, the related works are AlexNet, SqueezeNet, GAN, and DC-GAN. First, AlexNet was the winner 2020 IRSV-RC. AlexNet is characterized by using a large size filter and stride in the first convolution layer. Second, SqueezeNet shows the same performance as AlexNet, but has the advantage of using only 0.5 megabyte of storage space. Third, the GAN model is used as one of the technique of image oversampling. Finally, for this GAN, it is a model that compensated for the shortcoming of GAN, which we use only one channel. Proposed receive model. First, data collection. Dataset collection use portrait photo released on portal site. Dataset classification is conducted by gender and age, such as figure 6. This is the percent of data set for each class. The graph on the left shows the percent of data classified by gender, which will appear to be somewhat similar. And the graph on the right is the percent of data classified by age. We can see that the proportion of teen or younger data is relatively small compared to other classes. The following are the training results using original dataset only. The figure indicates that overfitting has occurred. The evidence can be seen by the accuracy and error of training and validation. The accuracy of the training set reaches 100% and the error reaches 0. However, the accuracy and error of the validation set show relatively poor performance compared to the training set. One way to solve this problem is oversampling. Let me deal with the story of oversampling on other pages. The models in this paper consist of total five convolution layer and max pooling layer, and 3 hidden layers. We also use RedLoop as the activation function for all layers. By doing so, we can quickly create a backpropagation process. The rest output layer use softmax to output probability value by class. This figure is model structure. Earlier, I talked about oversampling data as a way to avoid overfitting. That is the data augmentation. The first augmentation technique is to use the image data generator function provided by Keras. It is a way to create an image from multiple angles and recognize it as a completely different image in the learning process. The second augmentation technique is to use GAN. But as you can see, it didn't create a very good image. We are planning to improve this problem through future work. Overfitting can be solved by running image corresponding to each class to create new images that do not exist. And performance evaluation. The figure 13 show the result run without data made with GAN. I think images created simply by the image data generator function during the running process don't have much impact on oversampling. The figure 14 is a result of comparing the accuracy and error of the proposed model RedNet with the other two models. The figure 15 shows the result run with the made from GAN. The figure indicates that GAN oversampling technique is shown to be effective in running. This is a graph that compares the results of the previous models. This result is a result of the GAN image used for running. The table 3 shows the size of each model when it is physically stored. AlexNet requires 688 megabytes of storage space, while the proposed model RedNet uses only about 86 megabytes. SqueezeNet has less storage space but shows a performance that is lower than RedNet in terms of accuracy and error. Today I have shown you the paper that received CNN model for face image detection with GAN oversampling. I'd now like to recap the main point with this paper. First, embedded systems have severe constraints of physical storage space and computation. Then, to address the above problem, RedNet is proposed in this paper. Finally, this is GAN oversampling to avoid overfitting. Thank you very much for your attention.
Okay, thank you for presentation, Jia. Is there any questions? Okay, so now no questions. So I would like to one question for the presentation. Actually, I think you just comparing with the AlexNet and SqueezeNet for your proposal RedNet. What is the disadvantage? I think your proposed algorithm quite high performance, but I think your model have a little bit disadvantage. So could you introduce your papers?
Okay. First of all, as I mentioned briefly earlier, the GAN generated image is not stable, so it is not normally run enough. Therefore, we will study the GAN model that can create model meaningful image for future work. We also plan to conduct research to increase the reliability of our model using the REST XAI.
Okay, so thank you for your answering. Actually, previously I just took a keynote speech. So you guys consider the XAI with the GAN modeling, I think. So it's great idea. Thank you for presentation. Okay. So